Okay, good afternoon. This is Professor David J. De Los Reyes. My topic again this afternoon will be diodes. Uh, there are so many types of diodes. For this afternoon, I will be showing you a switching diode for a switch mode power supply. This is a high frequency diode in which it could rectify high frequency ripple. This diode here is another type of diode. We call this the so-called Zener diode. And this Zener diode is actually used for as a voltage regulator. Voltage regulator meaning Zener diodes. I got so many Zener diodes here. The range of this is 6.2 volt. So if you want the voltage of circuit to be steady at 6.2 volts, use this 6.2 volt Zener diode. The next one, what's this? 9.1. Okay. It will adjust the secondary voltage of the transformer to a 9.1 volt steady value. That's why we call it a voltage regulator, a Zener diode. This Zener diode here is 5.6. This could be the power supply of microprocessors maybe, because the voltage input to microprocessors is actually 5 volt. So there's a little bit higher. So if we use 5.6, well, that will be fine, because later on there should be a voltage drop. So when it powers up a microprocessor, it will go to 5 volts, because microprocessors are actually very sensitive. If the input voltage to microprocessors actually are below 5 volts, it will not function correctly. We got 6.8 Zener diode, and we got an 8.2 volt Zener diode. Okay, my main discussion for this afternoon is actually I discussed a Zener diode and a switching diode. So what I will be presenting is actually how to troubleshoot diodes. Okay, I don't have the rectifier diodes that is set for 60 hertz. That's the what you call this, the color is different, but it is still a diode. These two diodes are actually a diode. This is a switching diode for high frequency switch mode power supply, and this is a Zener diode for voltage regulator of what you call this, special circuits. Okay. Okay, I will try to bring out how we troubleshoot Zener diode out of circuit. It's not in the circuit. The symbol for a Zener diode, for a diode, will be something like this. We got the anode portion here, and this is the cathode. And current can only pass in one direction, from anode to cathode, right? So I would like to show you that a good diode will pass only current in one direction. We could check it, because if the diode passes current in one direction, and when the current reverses, it passes again, that is not a diode. It is not a diode, because a diode is just like a one-way switch. It will only pass current in one direction, so it could rectify alternating current. Okay? The instrument to troubleshoot a diode, whether switching diode or Zener diode or rectifier diode, the ordinary diode, okay, it will be the multitester set on the diode range. You see the symbol, the diode over here? So this is the pointer or the location of the tester, which tests a diode if it is good or not. Okay. Okay, I will start with the switching diode. A switching diode, a diode will only show a value on the tester one way. Okay, and what will come out on this multi-tester? Hold on. Overload. Okay. I have connected already the terminals of the tester, which is set to diode, okay? And I got a reading here is of 0.653. 0.653. This is the so-called forward bias. This is the direction when a current will pass through the diode. There is a reading, 0.652 something. Okay? In this connection, current could pass through. Okay? I will try to reverse this connection. Okay? If I try to reverse it, this will be the reading. It's an OL. Current could not pass through. Right? So this is the so-called reverse direction. That is when the negative alternation will pass through, it could not pass through because the diode is actually an open circuit. So this diode is actually okay because in the reverse direction, okay, it is open. But if I will try to reverse this one, okay, the connection. If I will try to reverse it, the reading is 0.652. That reading 0.652 meaning this diode is passing current, right? And the value is 0.652. Just beware of the value of the voltage because if the reading is 0.2 volt, that's no good. But for a good diode, the reading should be 0.6 something, okay? 0.6 something or 0.8. But if it is the value is low, it's 0.2 or 0.1, that diode may be on the verge of destruction already. So I am telling you, this diode is okay because in the forward direction, okay, it passes current. Why we know it passes current? There is a voltage drop reading here. It passes current. The reading is 0.652. Okay? So for the passive alternation, this is the way how the current enters the diode. It will start from the red thing, it passes through the diode, then it go to the black terminal. It passes the current. Okay? Okay, I will try to reverse this one. Okay, I reverse it. Oh, what's the reading? It's an open circuit. So in the reverse direction, okay, when the alternating current reverses direction, the current could not pass through. Okay? So this is a good diode. We call this switching diode for switch mode power supply in the frequency range kilohertz, which is needed for digital televisions, our gadgets maybe. Okay? So the current output of this, if you try to filter out, it is very smooth by using this high frequency diode. Okay? Okay, I will show you the Zener diode. The testing for a Zener diode is the same as for the switching diode. The only difference is that the Zener diode is used as a voltage regulator. It is used to set a certain voltage to a specific, okay, integrated circuits in a circuit. Okay? Okay, I will try to connect the terminals. I will try to see if this diode is good or not. For the meantime, I just don't even see the polarity. Where is the cathode, where is the anode? I just connect the two terminals. Okay, it is set on the diode thing. And our first reading is actually open circuit. Okay, it could be that this connection is the so-called reverse connection. So I will try to reverse the connection. Okay, I reverse it. I change the black to minus and the red to the plus. Okay, when I reverse it, there's a reading of 0.622. So this orientation now is actually the correct orientation. This is the anode, this is the cathode. Okay, and since there is a reading 0.623, this should be the so-called forward bias direction. This is the direction in which the positive alternation of a current will pass through. Okay? So this Zener diode is okay. Okay, I will try to reverse because the reverse of this should be an open circuit. I have told you a while ago that the testing for a diode is that in one direction there should be a reading, in the reverse direction it should be an open circuit. It will not pass through a current. Okay, I will try to reverse the connection now. Okay, I reverse it, and what is the reading? It's an open circuit, right? When the negative alternation passes through, starting with the red thing, it could not pass through the diode because diode is actually designed to only pass current in one direction. That is when the anode is positive with respect to the cathode. Okay, so this Zener diode is okay. Okay, I will reverse again to show you that this diode is okay. This is actually the anode portion, this is the cathode, and that is the direction in which the positive alternation will pass through. This should be plus, and this should be minus for a current to pass through here. Okay? And as we could see it, there's a reading. There's a reading, meaning current could pass through in this connection. That's it. That's the proper way on how to troubleshoot a diode out of circuit. You take one reading, the first reading, it could either be 0 or a certain value, okay? But the proper procedure is this. In one direction, there should be reading. In the other direction, it should be 0 for a diode to be okay. So for a Zener diode or a switching diode, the proper way on how to determine if they are good is actually in one direction there should be reading, in the reverse direction there should be no reading. Good afternoon from Los Angeles.